Okay, welcome everyone to Guided Study Group Week 2 of Stat 100. If you guys join me online or rewatch this video, feel free to stop me at any time if you need like a moment or to think about the problems, or maybe like just stop me from talking and try to like digest the information. That's completely fine. For those of you joining me online, I think that might not be possible, but you can mute me when I was going through the examples just to like, you know, um, and you can listen to it later. Don't worry. So I'm gonna get ahead and get started. It's similar to every week. We're gonna go through the materials again and like just very briefly some of the main points that you guys have to kind of like know and pay attention to. And if you don't, which means that okay, you might need some review on the lectures and all of that. And then we're gonna have some review questions. So as I said earlier, last week, um, statistic 100 doesn't have that much calculations, so life shouldn't be too bad, but more is about concept. So this thing this part of the materials can be a little bit hard to understand, but we're gonna figure it out together. So it's lesson 3, characteristic of good sample surveys and comparative studies. So some of the things concepts that we need to know in this chapter is that we need to know what is census and what is sample and what is the difference between them. So census is kind of like a survey that you try to do the survey for the entire population that you're investigating. So say if you're interested in the American populations, that what American, a typical American think about football or tennis or whatever it is. So then when you decided to do a census, either for a demographic purpose or whatever, it's you're gonna have to survey the entire populations that you targeted, and the the kind of like the informations, like those variables that you get and from the census is gonna be called parameters. But for sample, it's gonna be statistic, and sample is just a small portion of the population, but it's designed to be representative of the populations, so that we can draw some conclusion about the populations by just surveying the sample. Now there are some terms in sampling that we need to know. Sampling frame is kind of like a list of sampling units. So kind of like when you choose a sample, sampling frame is where we're gonna pick out the subjects that we're gonna survey them. And usually the sampling frame should kind of like represent the populations. So it should be like a big one, or it's kind of like giving a big pictures of how population should be. Say if you want to like understand the American populations, and but you just do like surveying, say Pennsylvania or California, that is not a very good sampling frame because it doesn't tell us everything about American. So, and then another one is we have populations. As I said, populations is the biggest group of individuals, of objects that we can survey, and we want to draw some conclusion about. In reality, as I said last week, it's not very practical and convenient for us to survey everyone in the populations because of time, money, and other problems. So usually we're just gonna focus on sample. Sample unit is the smallest subjects in sample. So say if you sample, you're gonna sample like many different subjects. So each of the subjects is called a sampling unit. The sample, if it's picked by random selections, then it is one of the way that ensure that our final result is reliable. That's also something we talked about last week. And then we have response bias and non-response bias. So response bias is where you survey different subjects and each of them have different tastes. So that response bias. On the other hand, non-response bias is more about low response rate. So the person who actually answered the survey might have a different opinion compared to the one who doesn't answer the survey. So the result of the survey might not be representative because it doesn't include all types of opinions. Then we have one of the kind of like prototype process of sample survey. So the goal to do sample survey is that the purpose is to know about the observation of the populations. Then the step is going to be choosing an intended sample from a sampling frame, and you send out those survey. But we usually don't get all of the result back. Usually we're just going to get a portion of it, which we call an actual sample. So we only get the result from an actual sample back. Not every subject that we send out to is going to answer the survey. Then we have to evaluate in this sample survey, we have to evaluate if the sampling frame was representative of the problem, of the populations. So say if we want to pick a sample from there, it's how reliable it is to represent the big populations. And then another one is if the sample that get returns back to us, so the actual sample, is it representative of the intended sample? So we can pick someone from the list, but it's not guaranteed that whoever get back to us is going to be 100% of the big of like we ask 100 people. There's nothing guaranteed that 100 people is going to get back to us. So we have to evaluate if whoever sent us their response back, is it representative of what we already chose at the beginning. Then we have the concept of margin of error. So this is kind of like the heart of this lessons. So where we try to see like, okay, how reliable our data is. So the margin of error is measure the reliability of the estimate make on the survey data, and it's smaller when the sample size getting larger. In fact, it's directly proportional to 1 over square root of n, with n be the sample size. And this margin of error doesn't tell you anything about bias or other errors in the survey. It only tells us how the error is associated depending on the sample size. So what happened is that, say if we want to draw a big pictures about American populations, and we only survey say like 100 people, obviously the error over there is going to be much higher than if we do the survey for 10,000 people, because that one's going to give us the better pictures. However, when we're talking about bias and auto response, we don't use margin of errors, because we're assuming that the sample that getting back to us is 1,000 people, or like the intended sample to be 10,000 people. We don't talk about how many people actually get back to us and other problems. So in case many sample sizes are surveyed unbiasedly, 95% of the time we can conclude that. So say if we have a big populations and we can pick out a lot of samples from that population and survey them, and if that process is conducted unbiasedly, so in an unbiased manner, then we 95% of the time, so we can say that the margin of error, so say the error that we determine from our sample size will be we will have the difference between the actual that characteristic of the true population and that characteristic of the sample. The difference is going to be just within the margin of error. That's a very important conclusion in this chapter. And then finally, we have MOE interpretation, margin of error interpretation. So how do we interpret margin of error when we're given, say, okay, we have the result of some survey, and this is the margin of error? What can we conclude about our result compared to the characteristic of the actual populations? And that we're going to see in the review questions. And then we have sampling methods. So there are two big groups of sampling method: probability sampling and non-probability sampling. So the difference between those two is basically on the probability of the subjects being chosen. Is it known or is it unknown? If it's known, then no P chosen, and then the other one is unknown. he chosen. Therefore, we will have thing like in the probability sampling, we have different types. Simple random sampling is very simple. We just pick them randomly in the big sample in the big populations. Systematic sampling, so say we're gonna pick one person after every 10 people, or give me a second. Type of positions. Okay. Yep. So yeah, systematic is the one where we say like we're gonna have a rule of how to pick people. Multi-stage sampling is where do the combination of multiple type of sampling together. Usually it's just due to the specific characteristic of that questions being asked. They're gonna have those like guidelines of how to choose it. Then we have two specific sampling types that is kind of hard to understand through I was told that a lot of students previously in this course having problem understand them. So I try to like separate them in a sense. So we have stratifying sampling and cluster sampling. Stratifying sampling is where you have a big populations and there is heterogeneous, so they have different kind of characteristic, and you try to divide it into smaller and smaller groups of the same characteristics. So say if you have depending on regions, say you have American populations, you try to separate them into 50 different states based on wherever they resided in. So it's kind of like stratified sampling, and if you just select a small portion of each populations, that is stratified sampling. However, cluster sampling is a little bit different. You try to divide the population into many groups, but each of them will have kind of like the characteristics similar to the populations. So here, when you divide in the stratifying sampling, when you divide it, the smaller groups is gonna have just like a small characteristic of the populations, but not all. But here, when you do cluster sampling, all of the groups usually have the characteristic of the entire populations, and obtain sample by surveying everyone in that groups. So that's also another difference compared to stratified sampling. Then we have non-probability sampling. So this is where legit we just choose something randomly and the probability is not even known. So there's not a specific types of sampling that we can call in non-probability sampling. It's just tell us about two types that we need to avoid, and which is going to be volunteer samples and haphazard samples. So these should be avoided because it usually doesn't give us the representative sample for the populations. Volunteer samples is usually just come from the people who voluntarily answer our survey, and obviously it's not going to capture the entire populations. Haphazard samples is where you take a samples by convenience and it doesn't really give us, maybe like it might not represent the big thing, it's just for our convenience to take like a small portion of the populations. Yeah, it's not common, usually it's biased and unexplainable. Now, some terms in comparative studies, and these are pretty basic. Some of them we already go over. So experimental unit is the smallest basic subject that can be assigned a condition of treatment. So basically it's just one of the subject that we try to study. So say if we want to study American population, so every single American citizen is one of the experimental unit. Then we have explanatory variable. It's one of the like some of the, say if you want to determine how exercise affect someone's height. So the explanatory variable here is going to be exercising, and the response outcome variable here is how is the weight of each person, depending if they exercise or not. So those are the very easy things. So say if you want to learn the effects of something on something else, so the parameter or like the factor that you're going to change to see the effects on different subjects is going to be explanatory variable, and the result that you have is going to be response variable. So treatment is one kind of explanatory variable. So depending on the subjects, so if you apply different treatment on that, then that's one of the way that we can. It's kind of like overlapping with the definitions of explanatory variable a little bit. Then we have something called confounding variable. So these usually arise when we design a study and we like change some variables and then we get the result. But then when we evaluate if this result actually makes sense and we come to think about some of the other factors that might affect our result, these confounding variable is the one that will affect our final result, but we didn't want to study the effects initially. So say this is some of the unexpected factor that arise in between, but can change our result. So yeah, then I will say this is the last part. So we have the summary of the 4 samples. So we have some types of samples depending on what type of study we have. So if we have an experimental sample and we have experimental study and 2 independent samples. So we're gonna have treatment, like how you put each subjects into each group is gonna be chosen by random, and then usually that's randomization will help us eliminate the effect of confounding variable. We also have experimental with 2 dependent match pairs. So this is randomization occurs not only in whoever received the treatment, but also the order that receive the treatment. So the more randomization you actually apply in every study will get rid of the effects of the confounding variable. Then we have observational studies and also the 2 matching types. And usually in observational, as I said last week, we cannot intervene in the way they are, and usually the treatment and the order of treatment is not randomly assigned because it's already in the nature of the subjects. So the effects of the confounding variable is always there. And there's some ways in scientific study or some other in research that they try to improve this problem by using a case control study. So we're going to have 2 groups. One group is going to be control variable and the other one is the control group, and the other one is the uncontrolled group, is where we where they have a different conditions. Say one group have cancer and the other one doesn't, but they have the same characteristics throughout their life except for the cancer part. So it's when you have to choose the subjects that you want to test first, so the one that have a special condition that you care about, and then you have to find other subjects that have the same situation, social situation with that person. They just don't have the disease. So they compare those 2 groups with one another. But this treatment, this kind of like improvement is a little bit hard to find because it's really hard to find someone with the same social or like situation or the growing up process with the subject that we're testing. And then we have prospective study. So prospective study is just one of the give me a second pulling it up. So prospective study is when you kind of like observe subjects over time and see how different exposure to one of the conditions can affect their result. But this is also usually hard to do because there are so many different variables and things that you cannot control in a person's life or subject's life. So like how they, even like how much they expose to the sun, how much they eat, what is their diet, all of those things cannot be controlled at the same time. So those are still, I mean, these 2 improvement can like get the result of observational study more accurate, but it never actually get rid of the effects of confounding variable. Now we have some practice questions and problems. So since no one actually joining me right now, feel free to post me before when you see every questions to like get some maybe 2 or 3 minutes think about it, because no one's actually joining me here. So for the sake of time, I'm just gonna go through the answer, and then after you have think through, you can start the video again to see what the answer is. So question 1, which of the following surveys would have the smallest margins of error? And we all know, like, when we talk about margin of error is proportional to 1 over square root of n, with n be the sample size. So here we have the margin of error. Here is going to be, with this, is going to be proportional to these numbers. So let me think about it. So it's asking which one have the smallest margin of error. So when we look at these fractions, the smallest of each of them, it means that the denominator is going to be bigger. Just think about it, you have 1 over 2 and 1 over 3. Which one is bigger? 1 over 2. So it has a smaller denominator but a bigger overall fraction. So here's the same thing. You have a bigger denominator, the smaller overall fraction. So here, which means that we're going to pick the one with the biggest denominator, which is square root of 1,200. So the answer is going to be B. Again, anytime during these sessions, if you don't understand something, feel free to email me at htt.5011@psu.edu to let me know what you need help with. Then we have question 2. Again, feel free to pause me anytime and work on this on your own. Suppose a sample of size n equal 500 is surveyed for the approval of the modernization plan for a small town in Iowa. 62% answer yes, with the margin of error of 3%. Given that the survey is conducted in an unbiased manner, how do we interpret the MOE? Now, before we look at the final answers, one thing that you actually should recall is that, okay, on what basis, what kind of statement or what part of the materials are we trying to use to solve this part? Is where we talk about, look at the keywords here, we interpret the margin of error. And so there's only one line that I actually mentioned in the previous review. It's saying 95% of the time the MOE is going, so the difference between true population characteristic and sample characteristic is going to be within the range of the MOE, which if we try to find that sample in about 95% of all samples this size, the probability that the sample doesn't equal the population percent, that the sample percent doesn't equal the population percent, is probability as the sample doesn't equal that is 3%, which doesn't have anything to do with this statement. So so this is not the one that we're looking for. Then there's a 95% chance that the sample percent is more than 3% lower than the population percent. Well, we say that it's 95% chance that the sample is going to be within this range of the MOE. So it cannot be more than that, the range. So it's not right as well. In about 95% of all sample this size, difference between the sample percent and the population percent will exceed 3%. That is also not true. It's going to be within 3%. So the last one, there's a 95% chance that the sample percent and will be within 3%. That is exactly correct of what we're looking for. So I would say this is not just for statistic 100, but for every single other subjects that you're dealing with. Whenever you have these type of questions, especially when you have a lot of words and it's really confusing, don't look at the answer choices. When you look at the questions and try to understand the questions, think about on what basis that you can draw your conclusion on, and maybe like have some general idea about, okay, how the result is going to look like before you jumping into reading the answer choices, because it's really confusing to look at the answer choices sometimes. So now we're going to go to question 3. Again, pause me now if you want to work on it on your own. In order to survey the opinions of its customer service, Telstra decided to use survey its user, particularly those who experience at its two largest locations out of its 60 store in Melbourne. I don't even know if it's the right number, and I'll just make it up. Everyone who come to Telstra at Cheston Shopping Centre and Melbourne CBD Hub will is given a link to fill out the survey in store. What type of sampling is it? Now, we look at the total in Melbourne. Telstra have 60 stores, so this is the populations that Telstra is looking for in. So the population is targeting is users in Melbourne, and it only pick out two largest the people who experience at these two largest locations and survey everyone there. Now it sounds very similar to cluster sampling, and it actually is, because at these two largest locations, what usually happens with users is that it's gonna attract most of the people in the city. So you have all kind of people that's gonna come to the two largest shopping center in the entire city or state. So we can consider that these two groups they possess the characteristics similar to the populations. So that is one conditions for cluster sampling, and the other one is that they survey everyone in these two groups. So it's definitely cluster sampling, and as we learned earlier in the review, it's one type of probability sampling. Now, again, if you have any questions, feel free to email me. If not, we're going to proceed through with question 4. So in question 4, saying, again, pause me if you want to work on it alone. Ultimate you have a group of 90 participants who want to lose at least 20 pounds in 6 weeks and provide training and diet suggestion based on their gender and age. After 1.5 months, they've waited again to determine if goal is achieved. What type of study is used here? Now, when we have 90 participants, and they receive training and diet based on their gender and age, and then they're weighted again. So they have two sets of data: the data before they receive the training and 6 weeks after they receive the training. So it's two dependent samples on matched pairs. Now, if we have to determine if it's experimental or observational. A lot of my students make a mistake thinking that this is an experiment because you give them treatment, right? You give them training and diet. But one thing you need to think about is, for experiment, you need randomization. Here, they receive training and diet based on their gender and age, something that you cannot randomly assign, which means it doesn't satisfy the conditions for a randomized experiment. So it's an observational study, which make the answer be D, observational study, two dependent samples or matched pairs. Again, be very careful about this part. Don't just look at every study and when they say something similar to treatment and you just go immediately to randomized experiment. Remember, it's called randomized experiment because it needs randomization, right? So we'll have 2 more questions. So question 5, Amazon wants to determine what % of all Australians favor Amazon pickup at station to reduce the cost of its transportation network. A random sample of 2,500 Queenslanders was obtained from a list of all Queensland residents. What is the major problem with this survey? Now, look at the goal of the questions to see what they give us. So Amazon want to determine % of all Australian, but a random sample of 2,500 Queenslanders was obtained from Queensland residents. So it wants to draw a conclusion by just surveying the people from Queensland and only take a portion of the populations. So the major problem with this is that it's choose kind of like a part of the populations that is not representative of the populations. So that's where it's related to sampling frame, and this actually is the answer. Now look at the rest. Obtain a volunteer sample. It doesn't actually mention anything about volunteer, so it's not right. Obtain a convenience sample. It doesn't say anything about convenience, even though it can imply that this is for the researchers' convenience. But it doesn't say that like clearly and directly, there's nothing that you can make conclusion about. And then finally, fail to obtain a complete census. Well, if this is the problem, then every single company, marketing company, is going to be in problem because none of them will have any census ever. So this is one of the, well, technically, theoretically, this is one of the problem of every single survey in reality, but it will not be a problem here, not a major problem, because a more important thing is that they're trying to draw the conclusion from every single Queenslander. And you can see here in the problem statement, they don't say anything about how Queenslanders represent Australians. So that is not the answer, even though it's like a minor part of the problem of these questions. Now we have the last questions again. Pause me, but I think this one is really quick, 30 seconds, so you guys can work on this with me. What are the types of randomization needed in matched sample pairs, and what's the role of randomization? So when we have matched pairs, not only do we have to choose the subject randomly, so first one, randomly select the participants. Second one, randomly assign them in groups, also correct, because that's like the general the general idea of randomized experiment. So this is when you have randomized experiment, when you put them in this different group randomly. Randomly select the participants. So this one is where you select the sampling technique. And then we have, because it's matched pair, you also have the extra randomly assign the order of treatment. So this is where you, because of matched pairs. Therefore, I think I forgot something about the role. But yeah, that is, which means we need the answer, all the answer is all of the above are correct. So that's all I have for today. If you have any questions, please feel free to email me. Final note, all of the review sessions is going to be found in my YouTube channel, and you can just go directly to Statistic 100, Summer 18 to find these videos. You don't need to click on different links to find them. There are also some playlists for Calculus 1 and 2 if you are interested, because I also do those classes. Next review is next Thursday at May 31st. Woohoo! One day from the International Children's Day. Anyway, if you have any questions, again, email me. And that's all I have for today. I'll see you guys next week, and have a great weekend, guys.